Hello friends, I am Satyendra and today in this video I am going to explain you that how to solve this question. This question was asked in CSIR. This question was asked in CSIR net December 2013. Okay, so in this question was based on quantum mechanics. Okay, and I am going to tell you the method that is used to solve this type of questions. Okay, so let's read the question. So a spin half particle is in the state. So the spin half particles are those particles which have the value of spin as equals to 1 upon 2. So these are called spin half particles. Okay, so the spin half particle is in the state. So the spin state is given by this. So this is the spin state, okay, of the spin half particle. Okay, and in the question it was given that this spin state is in the basis of s square and s z. Okay, so further, if we measure the sz, okay, if we measure the sz, okay, the probability of getting plus h naught over 2 and minus h naught over 2 r. So the answer is 2 over 11 and 9 over 11. So there are two answers because they asked us the probability of getting this and this. Okay, okay. So in order to solve this question, let's see the solution. Okay, how we did it. So it was given, okay, given the spin state is, so they gave the us the spin state is here. Okay, it was given in the question. Now this spin state can be written like this. Okay, okay, if you solve this much, okay, then you will directly get this. Okay, so I can write like this. Okay, okay. Now our next step is, okay, so the first thing that you will ask me at this point is that the first thing that you will the first question in your mind will be why I have taken this and this as the basis here. Okay, so the answer is that in the question they have already given us that this state is in the basis of sz. Okay, so that's the reason why I have written this state in the basis of sz. Okay, these are the basis of sz, that's why I have chosen this one. Okay, okay. Okay, now our next step towards solving this question is that now you have to compare your this equation with this equation. Okay, okay, so you can write this equation. Okay, okay, so in this equation, as you are looking at, these phi 1 and phi 2 are the eigen bases of sz. Okay, 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 and this c1 is the coefficient of phi 1, C2 is the coefficient of phi 2. Okay, now you might be wondering why I'm comparing why I'm comparing 1 minute. You might be wondering why I'm comparing this equation with this equation, and that will become clear to you. Okay, so right now you just have to compare. Okay, in quantum mechanics we have, while solving we have to do these things. Okay, so but don't worry, everything has reasons and you will become familiar with all these things slowly. I'm not going to tell you too much details because you will divert from our current topic. Okay, so right now what we are doing is what you have to hear. Okay, now if you compare your this equation and your this equation, then you will find that C1 is equals to this. Okay, and your C2 is equals to this. Okay, so this is what you will get on comparing these two equations, as well as you will find that this phi 1 is equals to this one and your phi 2 is equals to this one. Okay, so this is the thing that you are going to get. Okay, now before solving this question you have to know some concepts. Okay, so I'm going to explain those concepts. So first thing that you should know is that the eigenbasis of sz. Okay, the eigenbasis of sz are this one and this one, so it is very important to remember this. Okay, now here sz is the operator. Okay, and when this operator operates on the eigenbasis, or here the eigenfunction, it gives back the eigenfunction with an eigenvalue. Okay, so this is the eigenvalue, so this whole is the eigenvalue equation. Okay, and this h naught over 2 is the eigenvalue. Okay, so as I have already told you, phi and phi is okay. So I can write right now. What I can do, I can now write this equation. Okay, I can write this equation in this form. Okay, now as I have already I have also told you that this is also the eigen value, or the sorry, eigen function, or the basis of sz. So if you operate your sz over this eigen function, then you will again get back your eigen function, and the eigenvalue for this eigen function is here. Okay, which is minus h naught over 2. Okay, so as a whole I can write this equation like this with the help of phi 2. Okay, now I have to tell you some more things. Okay, so what is the measurement? Okay, now you have to understand the measurement. So now the measurement of sz means solving the eigenvalue equation of sz and finding out the eigenvalue. Okay, the eigenvalue is called the result of the measurement. Okay, so what here we are I'm explaining you is that you know that in quantum mechanics every physical quantity has the operator. Okay, so you may also know that, for example, if I'm going to explain you in too much in little detail, then let me explain you. Okay, so what happens in quantum mechanics, for example, you know that energy also have the operator. So if you want to know the energy of the if you want to know the energy okay, if you want to calculate the energy of some system, okay, so what you actually do is that you operate your Hamiltonian operator on the wave function, and you again get back the wave function with the eigenvalue. Okay, so this is the operator corresponding to the energy. This is the energy of the system, which is called the eigenvalue. Okay, so in order to find the energy, you have to operate the wave function with the with the operator of the energy. So in quantum mechanics, for everything, for example, if you want to calculate the position, if you want to calculate the momentum, you have to operate the corresponding operators, and then you have to get back the eigenvalue. Okay, you have to get the eigenvalue, and that eigenvalue is the result of the measurement. Okay, for example, so if you want to measure the momentum, okay, so you have to take the momentum operator, you have to operate the momentum operator on the wave function, and when you will solve that, you will get back the wave function with the and an eigenvalue. So that eigenvalue is your is your momentum, and that's the result of the measurement. Okay, so this is what here it was written. Okay, now now the probability, now if you measure sz, okay, if you measure this sz, the probability of getting h naught over 2, so this is the eigenvalue. Okay, this is this eigenvalue, and if you want to know the probability of this eigenvalue on the measurement, then that is simply equals to the square of the coefficient of phi 1. Okay, and that's the coefficient is c1, so it is equals to, the probability is equals to this much. Okay, so you can also see here that, so you can also here you can see that c1 is the coefficient of phi 1. Okay, and phi 1 has the eigenvalue h naught over 2, and if you want to know the probability of this h naught over 2, okay, then you have to find the this is c1, that you have to find the c1 square. Okay, so that's the way. Okay, so you have to know or remember all these things, all these way of finding these things in quantum mechanics. Okay, so the probability of getting the eigenvalue h naught over 2 is equals to the coefficient of phi 1 then whole square. Okay, and that is equals to c1 square. Okay, and the probability of getting the eigenvalue minus h naught over 2 is equals to the coefficient of phi 2 then square, and that is equals to this much. So that's the thing. So now let's see. Okay, so let's calculate this much. Okay, c1 square. Okay, so let's calculate it. So as I already explained you why we are comparing. Okay, so previously you were thinking that why we are comparing, and I told you that later you will understand the why, the reason of comparing. So you have to find out the value of c1 from by comparing these equations. So c1 is equals to this much. Okay, so let's plug the values here. Okay, so I am plugging the value here, so you can see that this is c1 whole square. So here also you have to carefully look at this point. Okay, so what is this? So okay, so if you know the complex numbers, then you might know that if z equals to, okay, if z equals to x plus iy, okay, and then the conjugate of z is x minus iy. Okay, and we also know that the mod of z equals to x square plus y square. Okay, so these are the things which we know very well. Okay, so let's see that if what will happen if I will multiply this z and z conjugate. Okay, so let's see that. Okay, so this will be x plus iy and x minus iy, and this on solving will give you x square minus iy square. Okay, and when I will further solve this, then this will give me x square plus y square, and this is equals to z square. Okay, so you can directly see that this is equals to this much. Okay, so this is the way why I wrote this thing. Okay, So I hope now this is clear to you at this point. Okay, so I'm just plugging the values. I have taken the conjugate of the complex number and then it multiplied with that complex number, and on solving I get this 2 over 11. Okay, and let's now find out this quantity. So this is also solved in the similar fashion. Okay, and this then equals to this much on plugging the values, and on solving I get 9 over 11. So I got 2 over 11 and 9 over 11 as the probabilities, and which is my answer. Okay, which I already told you. Okay, so we have got how we get this answer. So thanks for watching this video. Okay friends, thank you very much.